So now we're going to look at a way you can steady the output voltage of a Trimpot when the supply voltage changes. So we have a Zener diode parallel to it. It's a 5.6 volt Zener diode, so I can go up to about 5.6 volts or down to about 0 volts. We have 7 volts at the supply, as we'll look at. Of course, we have a 1000 ohm resistor that's mostly setting a current through the Zener diode. But in any case, I want to set this to 3 volts, and I did a really good job right there. Pretty much spot on 3 volts. So we got 7 volts at the supply. Again, we're going to need a couple volts more than the supply voltage, but I'm going to bump this up to 15. So we basically doubled, I'm just going to keep the math really simple, the supply voltage. So if you just had the Trimpot across the supply rails, then our output voltage would have also doubled 6. But thanks to the Zener diode, it held pretty steady there. It's going to change slightly, but for the most part, it's the same. So now here's the schematic diagram. Again, we want the output of the Trimpot, whatever we set it to be the same even as the supply voltage changes. So we're going to have to work within the limits of the Zener diode we use, and we're going to need about 2 volts, at least 1.5 volts more than the Zener voltage, in order to maintain that voltage. But in any case, 1000 ohm resistor, we should be able to get enough current right there to maintain about 5.6 volts across the Trimpot there. So then we can set it anywhere within that range. And as we raise the supply voltage, it doesn't matter. As more current flows, it just goes through the Zener diode. It maintains that voltage across the Trimpot, and thus the output voltage remains the same. So pretty simple, but pretty effective. And there's the actual circuit. I had the multimeter. I had to take measurements, so that was kind of blocking things, but hopefully that's easier to see.